Hey, hello everyone. I'm Arjun and I'm here to take you along a walkthrough of the 3 mark questions from Module 3. So, the first question is, what are the main differences between centralized and client-server database architectures? So, as we all know, in centralized database architecture, the entire database is stored and managed on a single central server. The terminals therefore depend fully on the central system for processing. Simple design but suffers from single point of failure and limited scalability, which is one of the greatest disadvantages of centralized database architecture. But when we come to client-server database architecture, here the workload is shared. Client sends requests, server processes them. Clients handle user interface and some logic. Server handles data operations. So here it is more scalable, efficient, and suitable for multi-user environments. The next question is, mention 3 advantages and 3 limitations of centralized server systems. So, looking into the advantages, the 3 advantages are easy maintenance, strong security, and less data redundancy. In the case of centralized server systems, all data and operations are in one place, hence it is easily maintainable. Since a centralized control simplifies protection, it also offers strong security. Here, it avoids duplications since data is stored centrally, ensuring there is no data redundancy. When we take a look into the limitations, there is only a single point of failure. That is, the entire system fails if the server goes down. Performance bottlenecks. Heavy load slows down the central machine. Limited scalability. Hard and expensive to upgrade a single server. Next question is, define parallel database systems and how do they differ from distributed databases? Parallel database systems, a system that uses multiple processes and storage units working simultaneously to improve query performance, speed, and throughput. Designed for parallel execution of tasks. Difference from distributed databases include parallel DBs are tightly coupled and usually within the same physical system. Distributed DBs are geographically separated and communicate over a network. Parallel DBs focus on performance, while distributed DBs focus on availability, autonomy, and data distribution. Next question is, what is data partitioning in a parallel database? Name any 2 common partitioning techniques. So, what is data partitioning? Splitting a large table into smaller subtables, partitions, and storing them across multiple processors enables faster and more efficient parallel query execution. 2 partitioning techniques which are commonly used include range partitioning, wherein data is divided based on a value ranges, example 1 to 1000, 1001 to 2000. And second one is hash partitioning. A hash function distributes data across partitions. Now getting into the last question. What is the purpose of parallel query processing and how does indexing improves its performance? So let's take a look into the purpose of parallel query processing. To speed up query execution by dividing query tasks among multiple processors, reduces response time and improves throughput for large databases, helps handle complex and heavy workloads efficiently. How indexing improves performance? Indexing allows quick data access without scanning entire tables, reduces workload per processor during parallel execution, and improves the speed of operation like selection, join, and aggregation. So that was all about the 3 mark questions from Module 3. Thank you.